Hello everyone. Today I will be discussing about the lab experiment. So I will be using one of the simulation tool called as LTSPICE, which you will get it from this website Analog Device. So you can download this from the website Analog Device for Windows 64 bits and Mac OS. This version you can download 17.1.15. So once you download this, so you can download this and you will be installing this software simulation tool. So once you install this, I have already installed, that's why I'm not installing it once again. So directly I will start with the tool for the explanation. So this is the tool. uh, First we will start with the simple clipper circuit. So for clipper circuit we need a simple diode and then resistor and then voltage source. So this is the diode which I'll be using. First we will be using with the parallel clipper. Voltage source I will get it from here. This is my voltage source, and resistance I will add resistance in series with the supply voltage. And to make the connection, this is how we make the connection for the circuit. And this is the connection of ground, and this completes the circuit. So now we will define the input voltage. So input voltage I will define it as a sine wave by going to the advanced option. Sine DC offset is 0, amplitude I will take 5, and frequency I will take it as 1 kilohertz. Okay, and the value of resistance I choose it as 10 kilo ohm. Okay, so now this completes the circuit. So if you want make any movement, you can select it from here, single click, and you can click it over here. So this completes the circuit. And to simulate the circuit, you can go to the option run over here, and the stop time I will give it as, since I have given input signal as 1 kilohertz, to see some 3 cycles I will use 3 milliseconds will be the stop time, and it's a transient analysis. So this is the simulation window. And to find out the waveforms, so you just go near the node where you want to see the node voltage. This is your input node. So when I click here, I will get to see the input voltage, which is V in 1. Okay, so now this is the output terminal, and when I click here, this is the output, and since it is in parallel, it will clip the positive half cycle, because when during positive half cycle this diode acts as a short circuit, and there will be a direct connection between this output terminal and the ground, and the output will be 0 during positive half cycle, and during negative half cycle this diode will be an open circuit, and this node, output node, will be following the same as input node. And you can also measure the output voltage over here. So I will check the first input voltage, which I have given as peak to peak as 5 volts. This is my input, 5 volts, approximately 4.9 it is showing, and negative minus 4.9 it is showing. This is my input voltage. And to check the output voltage, I will click on the output waveform. You can see here, this is my output waveform, where your positive voltage is 0 plus 0.6 volts or 633 millivolts, which is nothing but the forward voltage of this diode, right? So the forward voltage, minimum voltage required to turn on this diode, thus forward voltage will appear during the positive half cycle. Okay, so this is how you see the clipper circuit. And you can also analyze the transfer characteristics. To do the transfer characteristics, I will right click on this option what I have the SPICE code to simulate. Right click on the same, so I will get the same window, simulation command. So here I will do the DC sweep. So the DC sweep, for the DC sweep I am varying this input voltage V1. Okay, so this V1 I am varying it in a linear fashion, starting from -5 to plus 5 volts in a step of 0.01 volt. So this is the step, and here you see when I simulate this, this is the SPICE code for the DC simulation or the transient analysis, and you see this is the transfer characteristics of the parallel clipper. You see the input is in blue color, which is varying from -5 to green color is the input VO1, so it is varying from -5 to +5, and the output is blue color, which you see varying from the positive clipper. It is the positive portion is completely clipped, so the waveform will be observing from -5 to 0 plus 633 millivolts, which is the diode voltage, the forward voltage of the diode. So this is the parallel clipper and parallel positive clipper. So now I will modify the circuit same to negative clipper. I will delete this. So to delete, I will select delete button from the keyboard, and you will get this symbol. If you click left mouse button on the any device, that will be off. Okay, so this is how I delete the device. Now I will select the diode again and put it in the opposite reverse direction and to simulate the same here. You see directly I am running the transfer characteristics, which the SPICE code is .dc is the same transfer characteristics. So this is the, so now what happens, the input is in green color, which is varying from -5 to 5 volt plus 5 volt, and your positive portion is same as your input, and the negative portion, what happens, it is completely clipped. So this is 0 negative cycle, and the small voltage forward bias of the diode 633 millivolts is appearing in the output. So to do the transient analysis, again left click on this, select the transient, so same 3 millisecond time period, and I will simulate it once again. So this is how I see the output waveform. This is the negative clipper, right? So this is the simple negative and positive clipper, which you can see here. By also adding a different bias voltage, you can shape this waveform in a different waveforms. Okay, so now I will add the additional DC voltage for this. So I will delete the lower portion of this, and I will add additional voltage over here, voltage. So I will add positive voltage. Okay, so again left click on this, you will get this window to put the value. I will give a reference voltage of plus 2 volts. Okay, plus 2 volts reference voltage. So now I will simulate it with the plus 2 volts, negative clipper with plus 2 volt. So I'll run the simulation. You see, okay, I have not connected the ground for this, so that's why it is showing an error. Yeah, this makes the complete connection, and now this, you see, suddenly the output rises to voltage, certain voltage, which is 2 volts. Earlier it was 0, and it is now shifted to 2 volts, exactly not 2 volts. So 2 volts minus 0.6, 2 volts minus 0.6, what you see it as 1.3 volts. That means the forward diode voltage, you can see this. Okay, and similarly I can do it for the negative reference also. So this 2 what I have given, I will make it as -2, and you can see that sudden change in the output waveform when I run the simulation. You see now it is shifted to -2. Okay, and you can also see the transfer characteristics of this by doing DC sweep. So V1 is the input voltage which I am varying linearly from -5 to 5 volts in step of 0.01 volt. So this is the SPICE code for DC simulation. I will run the simulation. So now what happens, the output will follow from minus 2.3, what you have 2.6. The output will follow input from minus 2.2 plus 5 volts, and the remaining portion is clipped. You can see that in the DC analysis. Now you see, so the output is positive side is completely followed, and in the negative side it follows up till it follows, this is the reference 0 voltage. I will check the output voltage here, and it follows up till 2.5 volt. Okay, so this is how you do the clipper circuit. Similarly you can also do it for the clamper. So I have already done the circuit on the clamper. I will just open it and show the clamper circuit. So this is the clamper. So directly, so here in the clamper we are using a capacitor and the resistor, and we have discussed in the instruction class how to choose the capacitor and the resistor. Basically the RC time constant should be very large, so we are giving this R and C very much large, that it is greater than 10 times of the input time period. The input time period means input signal is 1 kilohertz, which means 1 millisecond. So the time period of this RC should be more than 10 times of that 1 millisecond. Okay, that you have to take care. And this is the output window, this is the input what you can see here, and this is the output what it is clamped, as we discussed in the instruction class. So this input waveform in the green color is the input signal, and the blue color is the output signal. So when I click on the blue color waveform, you can see that, so this is the new reference voltage of the zero origin of the output waveform, which has shifted from 0 to, so if you see here the reference of the input is 0. Okay, you can see here it is 0. Now the reference of the input is 4 volts, means along with the taking care of the diode voltage as well. Okay, so almost this output waveform is shifted from 0 volt to 5 volt. Okay, because I am giving the input signal from plus 5 volts to minus 5 volt. Okay, so by adding a reference, you can see here, this is, I am adding a reference, positive reference, and the positive reference of minus 3 volts. Okay, and the same signal it is. So you can see here, I will see the output of here with reference voltage of minus 3. Okay, so now the reference which was 0, this is the input, the reference of the input is 0, and this is the output of the circuit with minus 3 as a reference, and the value of that you can see it as minus 3 plus something, which is reference, means the diode forward voltage. Okay, so these are some of the clippers and clamper circuit, so which I wanted you to show it using a simulation tool. So you can also view the regular experiments will also be available in the website, which I will be sharing along with you. Okay. Thank you.